Hi guys, welcome to the maths lesson. So today we're going to look at some financial maths or finance and growth. In specific, we're going to look at compound growth. So we're going to explore what exactly does it mean and what are the big ideas, what are the concepts we're going to look at. But before that, let's just go back quickly and just recap on what we've done in our previous lesson. So we've looked at our big idea, which was growth, and then under growth we looked at what we call a pattern, the graphs and equations, and then the context played a very big role because we looked at society and then we looked at finance as well. And then what I wanted you guys to think about was, if we are describing growth using maths, we talk about whether there is a pattern, and we talk about whether we can develop a model to predict some growth. And then under patterns, remember there were three types: our simple, compound, and random. And then data, we had the concept of equations and graphs. So we can explore data using equations or explore data using graphs. Now with simple, remember our example of the exercise, which was the steps walked. The person decided to walk 5 steps on the first day, which was actually day 8 in this instance, Monday. On day 9, they increased by 100 and 100 and 100 like that as the days continued. So you saw that this had a constant growth of 100. So that's the simple growth. And then what we then looked at, our keywords, where we measure the change that is constant, which we just saw in the previous table. And then lastly would be the arithmetic pattern that we kind of spoke about. And then the last keyword was the gradient, which is the steepness of a slope. Now if we look at the concept of a gradient, the line will look something like this, which would then be our graph. And the graph will normally have a gradient, and it will also have an equation, which would be a model in this instance. The graph itself is also a model. That's one of the things that you need to know as well. Now, patterns in the context of finance, our key concepts there, or keywords, were savings. So remember, this was for a short period of time. Investment was for a very long period of time. Principal amount was the initial amount you start with. Accumulated amount would be the amount you get over a period of time. And then we have the interest, and lastly our interest rate. Now today we're actually going to look at some compound patterns. And then before anything, let's just look at some graphs and try and talk about this. Now here, remember, how we describe a growth using maths is we'll talk about whether there is a pattern and whether we can develop a model. Now you will see that with compound, it means, one, the change is there, growth is there, but it is not a constant growth like we've seen with our previous lesson. So that's what we are going to try and explore in great detail, and actually even get to doing some calculations with that. Now, if we look at some graphs, this is a graph that shows the spread of COVID-19 virus in India. Now, this was between the months March 2020 and November 2020. Now, if you look at this, between March 2020, or between the 0 there and roughly June here, because that will be June there. So between that and June here, you can see that it looks like there is no growth or there is no change whatsoever. But, so meaning the small change over a long time. But if you continue with this, you will see that from June up until roughly our August there, which is like 2 months, there was very rapid growth, which got us to 2 million number of cases. And then from the August until September there, you can see that it's now a very big jump as well, which goes to a 4 million, but now it's taking 1 month instead of 2 months, and then continuing like that. So you can see that now for us to have a big change, the time is a bit smaller. So what does this mean? It means when you talk about growth under compound patterns, we are saying the longer the time, your growth will be a bit small. But over a short period of time, then our growth, as you see here, is quite rapid. So that's what we're really going to be talking about. Now, if we look at compound growth, we can see that our change is not constant. The rate of change is also not constant. And then the time to double becomes smaller, right? So let's quickly just go back to that table. So you can see now here that from this point to that point, this went to 2 million, right? For it to double, it must get to 4 million. But 4 million, you can see roughly that it took actually a month to double, when it took maybe 2 months to get to 2 million. And then from September, you can see up until there, this is really not a month. It could be half a month. And you see it takes half a month for it to double as well. And then roughly up until you get there, you can see that it takes 1 more month to then double up as well. So what does this mean? Our rate of change through time, you can see that it's not constant. Also, our change is not constant, meaning the number of cases that I had here and the number of cases I have here, the difference between the two will not be the same as the number of cases that I will have at that point, which will still not be the same as the number of cases that I will have at that point. Also, not the same as the number of cases I will have at that point. And then lastly, not the same as the number of cases that I will have at that point. So this shows us that with the compound growth, we do not necessarily have a constant growth that we are talking about, a constant in terms of change, and then we are also do not have a constant rate of change going forward with this. So the big idea here, you can see under compound growth, the change is not constant, our rate of change is also not constant, and then the time to double becomes smaller. So what does this mean? It means time is of the great importance when dealing with some compound growth. But we will look at this further as we are continuing. Now, you can see that with all of this that we've spoken about, the main big idea here is with compound growth, we don't have a constant change. We don't have a constant rate of change. And the time that it takes for the change to double up is becoming smaller and smaller as you are progressing with the time that we are having. So that's all that I have for now. We're going to go quickly to an ad break, and I'll be back with some more. Stay tuned.